guys. Okay. I'm sorry. I'm still laughing at myself because this is my 8th time recording this. And I was a good 3 minutes into the last video and realized it wasn't recording. So yeah, sorry. So if you could update your table of contents, we're going to be talking about graphing exponential functions today. So that's going to be on my page 61. It'll probably only be one page, but I'm not sure. So I will update that when we are finished. Oh, it's been a long day, guys. So after you update your table of contents, turn to your page 61, please, and title it, and then we will get started. So if you could also see this setup that I have going on here, you would make fun of me for the rest of my life. So we're going to be talking about graphing exponential functions. So that is our topic for today. I'm trying to make it so the more of the page can fit. Okay. All right, so let's talk about graphing exponential functions. And the first thing is I need to introduce you to a new vocabulary word. And that vocabulary word is asymptote. So it's A-S-Y-M-P-T-O-T-E. Asymptote. And what an asymptote is an imaginary line it's an imaginary horizontal line. It can be vertical, but we're going to be talking about horizontal lines. So an imaginary line that the function approaches but never crosses or touches. Okay, so that's what an asymptote is. And about 4 years ago, I think it was my first year here when I was teaching in Bristol Warren, a student raised his hand and I thought he had something, really profound to add to the class. And I called on him and he said, so Mrs. Greenway, an asymptote is like the friend zone of functions. And I was like, okay. And he's like, well, because you can approach it, but you never get out of the friend zone. And I was like, you know what? You're right. So from that point on, I've always associated asymptotes with the friend zone. So it's the boundary line for the friend zone for a function. The function can come really, really close to it, but it can never touch it and never cross it. So if that helps you, then great. All right, so let's actually get into it. So let's look at a parent function for exponentials. So the parent function looks like f of x or y, right? They're the same thing, equals b to the x. So as you see, our x variable or our independent variable is an exponent, hence exponential functions. The b represents the base. Now, bases for exponential functions can be anything. I don't want to say that. Okay, so they can be decimals, they can be fractions, they can be whole numbers. They just can't be 0, or they can't be negative either. So b has to be greater than 0. So we can't have a negative base. So the thing that's different about exponential functions is that there's no one parent function. So the parent function for linear was y equals x, right? And the parent function for absolute values was y equals the absolute value of x. Well, the parent functions for exponentials can look like a variety of things. It can look like y equals 1/2 to the x, y equals 3 to the x, y equals 0.25 to the x. So that base can change. There's no one parent function. So the parent function we're going to be looking at today is we're going to graph the parent function f of x is equal to 2 to the x. So this is our parent function. It is not always 2 for a parent function. Okay, that is not a requirement. So if you see a 1/2 here in the base, it doesn't mean that it went through a transformation. All right. So the way that we're going to graph this is we're going to make a table. So we have x, we have 2 to the x, and we have y. And we're going to use the values -3, -2, -1, 0, 1, 2, and 3. Okay? So, remember way back in September or October, I think it was September, we studied exponent rules, right? So if I substitute that -3 as the x value in for x, I get 2 to the -3rd. And 2 to the -3rd is not -8, right? 2 to the -3rd is 1 over 2 to the 3rd. If you don't remember that, you need to go back and revisit your exponent rules. And 1 over 2 to the 3rd is 1/8. Okay? So then we have 2 to the -2. And 2 to the -2 is 1 over 2 squared, which is 1/4. Oops, I used purple instead of pink. Sorry. And then we have 2 to the -1st, which is 1 over 2 to the 1st, or 1/2, which is just 1/2, so I don't need to rewrite that. And then we have 2 to the 0. Please do not tell me 2 to the 0 is 0, because anything raised to the 0 power is 1. And then we have 2 to the 1st, which is 2. And then we have 2 squared, which is 4. And then 2 to the 3rd, which is 8. Okay? So if you are confused on anything here, here's our x, here's our x values. We substitute the x values in negative exponents. We take the reciprocal, right? And then that exponent becomes positive. And that's how we got the fractions. Okay, so let's graph these. Well, we're gonna sketch the graph. It's not gonna be precise, but we're gonna sketch the graph. And if you notice, I have no negatives in my y value. So I have my x-axis, my y-axis. I only went to 3 and -3, and I went up to 8. So 1, 2, 3, 4, 5, 6, 7, 8. So 2, 4, 6, 8. All right, so now let's plot our ordered pairs. So at -3, we were at 1/8. 1/8 is 0.125. So it is very close to 0. So 0.125. We're estimating, okay? At -2, we're at 1/4. So that's 0.25. So it's still very close to the 0. At -1, we're at 1/2. So we're halfway between the 0 and the 1. At 0, we're at 1. At 1, we're up to 2. At 2, we're up to 4. And 3, we are up to 8. Okay? So if you notice, we have a curve here. Okay? So your graph will look like this. And it doesn't matter how far into the negatives we get, right? So at -4, I would have 2 to the -4th, which would be 1 over 2 to the 4th, which is still a very, very small number. It's not 0. And then 2 to the -5th is 1 over 2 to the 5th, right? 2 to the -500th is 1 over 2 to the 500th. It's not 0. So as you can see, it's approaching 0. The closer we get to -infinity, the farther we get out into this end, the closer we're going to get to 0, but we're never going to get there. So this line right here is your horizontal asymptote. And we define it as y equals 0 in this case, because that is this horizontal line. It's your x-axis, but that means y equals 0. So that's your horizontal asymptote. So this function cannot ever have that value for y. So your horizontal asymptote also tells you your range, right? So our range would be y is greater than 0. It's not greater than or equal to, it's greater than 0 because y can never be 0. So our domain, I don't have any restrictions on my domain, right? I can go all the way to -infinity, and even though it looks like it's gonna start to go vertical, it doesn't. It can go all the way to +infinity for your x values, right? It looks like it's gonna become a vertical line, but it doesn't. So our domain is all real numbers. Okay, so we notice that we have a horizontal asymptote at y equals 0. One other thing that we can notice is that we have a y-intercept at 1. Okay. So those are really the two things that we can notice from this graph, that we have a horizontal asymptote at y equals 0, and we have a y-intercept at 1. Okay. So let's see what happens if we were to graph. So this would, I guess, be our example 2. Let's see what happens if we graph f of x is equal to -2 to the x. So I know you're freaking out, or you should be, because you should be saying, Mrs. Greenway, I think you made a mistake, because we all know that I do frequently. But I didn't make a mistake. I know I said here that my base has to be greater than 0, right? But here I have a -2 to the x. Do you remember back in October and November and December and January and February? Not March though. Actually not February, because I wasn't there for February either. But do you remember, you don't have to write this down. Do you remember me making a huge deal about the difference between this and this? -2 squared, or -2 in parentheses squared. Do you remember that I made a huge deal about that? And the reason that I made a huge deal about that is well, A, because of now, and B, because if I didn't, you'd get the wrong answer. So remember I said this is like multiplying -1 times 2 squared? Because the power to a power rule here, this squared only applies to the 2. Whereas here, this squared applies to the whole -2. So this would be -4, and this would be +4. Do you remember how I made a big deal about that? Good. So what you should realize then is that this is the same thing as -1 times 2 to the x. Okay? So we're multiplying our parent function 2 to the x, right? 2 to the x. I'm multiplying my parent function by a -1. And let's see what that does to our graph. So again, we're gonna make a table. So we have x, we have -1 times 2 to the x, and then we have our y value. So again, we have -3, -2, -1, 0, 1, 2, and 3. So if I do -1 times 2 to the -3rd, well, we know that 2 to the -3rd, we did that up here, 2 to the -3rd is 1/8. So 1/8 times -1 is -1/8. Okay? Does that make sense? I can't read your faces, so I don't know if that makes sense or not, but I hope that it does. If not, jump onto your Google Meet for your class, or shoot me an email. So -1, now my x value is -2. So -1 times 2 to the -2, so 2 to the -2 is 1/2 squared, which is 1/4. And 1/4 times -1 is -1/4. Okay, so -1 times 2 to the -1st. 2 to the -1st is 1/2. 1/2 times 1 is -1/2. Then we have -1 times 2 to the 0. 2 to the 0 is 1. 1 times -1 is -1. Okay, so then we have -1 times 2 to the 1st. 2 to the 1st is 2. Sorry, I almost said 1. 2 to the 1st is 2. 2 times -1 is -2. Then we have -1 times 2 squared. 2 squared is 4. 4 times -1 is -4. And finally, we have -1 times 2 to the 3rd. 2 to the 3rd is 8. 8 times -1 is -8. Okay? So, hopefully that makes sense. If not, you know what to do. Email me. Rewatch it. Go to Google Meet. So if we notice, now we have all negative values, right? And as x is getting larger, y is getting smaller. So I'm actually gonna make my graph up here. My x-axis is gonna be up here because I need all of the bottom 2 quadrants, okay? So again, I went 1, 2, 3. I don't know why I did such a long x-axis. And I went down to 8. So 1, 2, 3, 4, 5, 6, 7, 8. So let's graph it. So at -3, we're at -1/8, and that's -0.125. So -3, -1, -0.125 is very close to 0. -2, -1/4, -2, -1/4 is -0.25, so it's still close to 0. and then -1, -1/2. -1/2 is between 0 and -1, so -1/2 would be like here. And then 0, -1, and then 1, -2, 2, -4, and then 3, -8. And if I were to connect those, it would look like this. Okay? So let's talk about what we notice about our graph. So very similar, right? So no matter how small my x value gets, it's never going to be 0, because it's always going to be 2 to a negative power is going to turn that into its reciprocal. And then we're multiplying that reciprocal by a -1. So I'm never going to get to 0. So that means that my horizontal asymptote is here. So my horizontal asymptote is at y equals 0. Sorry. So what else do we know about our function? We know that our function has a y-intercept at the point 0, -1. How does that relate to the parent function? Well, our parent function had a y-intercept at 1. And now our y-intercept is at -1. So if you look, it's like I took this and I reflected it over my x-axis. So this graph was transformed, right? So our transformation, well, sorry, I'm getting ahead of myself. Let's talk about our domain and range. So our domain is still all real numbers. All my x values are going from all the way to -infinity, and then my x values are still going all the way to +infinity, even though it looks like it kind of goes off into a vertical line. So I have all real numbers. And my range, my y values can't ever be any larger than 0, and it can't be 0. So y is less than 0. That's my range. Okay? So the transformation that took place by multiplying the parent function by a -1 was that it was reflected over the x-axis. And that should sound kind of familiar to you with what we just studied with absolute value. So what you're going to do next is on Google Classroom, there are 4 examples, and it's going to take you through adding or subtracting from the parent function to x. So it'll look like 2 to the x plus something. So if you had like f of x is equal to 2 to the x and then plus 1, right? So we're going to graph that. And then we're going to graph 2 to the x minus 1. And then we're going to graph 2 to the x plus 1. So now the 1's being added to the x value. This is being added to the whole function. So hopefully you start to see a trend there, and then you can check your answers. The answer sheet will be up on Google Classroom. If you have questions at all, please feel free to join Google Meet. I'm going to be going between 4 classes tomorrow, so I'll be popping in and out. You can shoot me an email, you can Google chat me, you can sign up for a more one-on-one time, but that's it. And then you're going to be doing a different problem on a flip grid, and those instructions are all in that document in the lesson plan. All right, lovelies, have fun.